Hey everybody, Dave with Dave Life Adventures, and today we're looking at my window in the sliding door of my Tiffin GH1. Mine's a 2025, but yours is most likely the exact same as mine, as well if you have a Revel, Winnebago Revel, or an Echo, or probably, I'm not sure if the storytellers use these struts or not, but this is a Lippert window. And these struts here have been known to become problematic. There is a mechanism. Let's go inside the van and I'll show you the mechanism here. These are in the struts, and it is really a horrible design in my opinion. And they get locked up. The slightest little bit of dirt or sand or anything that gets in those struts, and it really doesn't have to be anything crazy. It can be just a little bit that got into it when you went down a dirt road or whatever. And the struts will lock up on you, and you can't move the window up or down. Sometimes you can kind of wiggle it a little bit and they'll release, but when they get jammed up, you don't want that to happen when you're out camping, and especially you get into a rainstorm or a dust storm or anything like that. You need to be able to close these windows quickly. There's a video out there on the solution that somebody came up with, and the YouTube channel is The Fit RV. The Fit RV. Go check that out and look for, you could search for acrylic window struts, I think, on their channel in their videos, and you will find a video on how to do this. But what he came up with was a 3D printed piece that goes into this T-channel here. And then you use a thumb screw to drill into the top of that, and it goes into that plastic. You may be able to see it here on the, if it can come into focus a little bit there. And that will allow you to use this thumb screw to press against this outer channel that it slides into. So there's a process to 3D print that and get it put in there. I won't go into the details of how that works because he does a great job in his video. The only thing that I did that was different really than what he did is I think he used PLA or PETG filament. I'm pretty sure he used PLA. My concern with that was that it gets pretty hot through this window when the sun's beating down on it. And if this is closed, there are situations where it gets extremely hot at this point. So I wanted to use a filament that would withstand those level of heats without it breaking down. And so I used ASA filament. So you may have also seen ABS filament, I think, out there as well. But ASA is what I used on this to just be able to withstand that heat. So now I'm really excited because to change the position of the window, let me get the other side here undone so that we can let this be a little more free-flowing quickly. So now imagine doing this on both sides, but you would do like a quarter turn and then you can move it up and down. You don't have to go all the way out in order to get it to close, but then it's in place. So just a little turn there, and you do this on both sides, and very easy to undo it and close the window all the way, and then you can of course lock it in from the inside. So I'm on my computer at this moment and wanted to just walk you through kind of what triggered all of this to happen in the first place. I ran across this article put out by the Fit RV, and it's acrylic window struts stuck, repair them for good, cheaply. And in this is a detailed article on how this process worked. James is talking about his Echo here. And as you guys know, these struts can be problematic, especially if you have, are in a dust storm or just over time getting salty air in it or anything. Sometimes the mechanism that is in these does not work so well and actually can fail. It can make the window get stuck open. It can also make it to where it doesn't even stop at the various positions there on it, like mine. So I'll show you a little bit later on how I actually go to repair that with following James' recommendations here. But great YouTube video out here going through this, and one of James' goals here in the video is to try to show everyone how to fix this with inexpensive tools and so forth. So I made a few modifications along the way, but I've watched this video quite a few times, had to pause it several times just to make sure that I knew what was going on and how things were happening. But it's a fantastic article and video, and he even goes to the level of sharing the various tools that he used and parts that he used. And probably the most scary part for those that aren't familiar with 3D printing, that's probably the most little bit scary part of the whole thing. I happen to have a 3D printer. I would not consider myself an expert by any means on this, but I thought I might walk you through how that part of this works and just show you. Things may vary a little bit based off of which printer you have and what software you're using to control that printer. I personally have a Bamboo 3D printer. It's an X1C or X1 Carbon. And I'll show you kind of how it looks in the interface there. But the first thing is he links to an STL file. Now, an STL file, for those that don't know, that is really the raw 3D model of the parts that you need to print, and that'll work with any 3D printing software and printer on that. There are variations of this, and I'm going to show you one variation that I've made specifically for my printer in a little bit. But if you click this link, it'll open up a site called Thingiverse, and there's quite a few sites out here, but this one in particular is where James decided to upload his STL files to. And this is it. That's what you're looking at. We're going to be printing these parts, and you can click the download link here to download that STL file, and it'll be named just like this. There's some additional information out here, but in short, you don't really need to know a whole lot about this. Now, one modification that I did make on this, and you may want to do this as well, James recommended PLA for this, and that is a softer material than I think would actually work well in this situation, because I would want it to last a bit longer. So for those that don't know, there's different types of filament that you can use in the 3D printers. And in this case, he's using PLA, and it's, that's the cheapest of the filaments, but it's also a softer material, and it may break down over time. So I chose to use ASA for my filament. Not all printers are going to support using ASA, but mine does. And because it is such a small model, you don't have to worry too much about the heating of the chamber too much in this. So if you don't have a heater chamber in your 3D printer, a heater for your chamber in the 3D printer, don't worry about it too much. This is a pretty small print. And as you can see, this is printing 12 of these. Depending on whether or not you're using this in a van, like a Tiffin GH1 or a Winnebago Revel or an Echo, you're going to need more or less of these. But in my case, it's a Tiffin GH1, and I am primarily concerned about the window that's at the sliding door. So I only needed 2 of these, but I went ahead and printed all 12 in one run anyway. It's a pretty fast print. But once you download the STL file, you'll have it on your local computer. And you'll see I have 2 files here. One is the STL file from James, and I'll open that up and show you here in my Bamboo Studio software. But I also created from that a .3mf file. And this is specifically will hold the settings that I chose to tweak from the STL here. and it saves all the settings, so I can make this available as well to anybody that's interested in using that happens to have a Bamboo Lab X1C printer. Let's go ahead and open up the STL file, and that should fire up my Bamboo Studio and load the raw STL file into it. And there are plenty of tutorials out there if you're new to this, or if you happen to have an X1C. There are plenty of tutorials out there on how to do a lot of this stuff in more detail than what I'm going to show you, but I'll show you the things that I tweaked in this as soon as it loads up here. Okay. So it is loading now. It's going to open up that STL file, and we'll see the model over here on the right. Now, there's different ways to look at this, but I'm going to zoom into it and kind of rotate this so we can see kind of what that looks like. So there's the 12 items, and I've got them selected right now, so it's kind of hard to see. I'll unselect that. Now you can see all of this. Now, the thing that I did, since he was recommending PLA, I decided to go ASA, and I knew I needed a little bit more precision with these, because if you're new to 3D printing, threading, when you try to print threads in this orientation, it's not necessarily the most precise print. So you'll see in James's article, he's talking about using a tap to make these threads more precise, and it works fantastically, by the way, and I'll go through that in just a minute. But one of the things that I did is I changed the layer height here to 0.1. That's usually the lowest that most printers are going to support. Your printer may vary, but I changed that one, and also I decided to use ASA for my filament, so you can do that by selecting the object, right-clicking on it, change filament, and I chose my ASA. Now I have what they call an AMS. It's an automatic filament feeder system, basically, so I can have 4 different spools of filament, and you'll see here I've got a PLA basic in black, I've got a PLA matte in white, I've got a gray ASA. I chose to use gray for that, and notice that my model changed once I selected the filament that I wanted to use. That's more representative of what it's going to actually look like when it's printed. I thought gray would be a good color because these struts are like an aluminum, so I thought that would go good. These are going to be tucked inside of the struts anyway, so it's kind of a moot point, but just aesthetically, I thought that would match a little bit better. And another thing that I did is I noticed that when you slice this and you start looking at the infill, is what they call it. Let me change this scheme from filament to I believe a summary here, or line type. There we go. When I look down at the infill here, it wasn't quite as much as I thought it needed to be, so I increased it just a little bit to make it a little bit stronger inside. But I'll go ahead and the other thing I did is notice the white that is showing up here. By default, depending on which software you're using and all, this may randomize. So one of the things I did was to come over to, see if I can find this here real quick. It's in the quality. Yeah, there it is. This is called the seam, and by default, most of these programs will use aligned. So I changed that to back, and what that means is it's going to move it to the back of the plate. So if I'm looking at my plate, this is the front of the plate, and this is the back of the plate. So what I like to do is to select the model. Let me go back into prepare. I'll select the model, and then I will use this rotate here, and I'll grab the blue one and rotate it 45 degrees and snap it to 45 degrees there. And then if I slice it again, this will all make sense in just a minute. What you want is the seam to be on the back side of the plate, so all the imperfections will be at the same place. and that'll help the look and feel of it a little bit. So you'll see a little bit later when I show you the actual prints of these. They're all uniform in exactly the same place. So that's just one little minor detail to look at. And then once you're happy with this, you can just print the plate, and that'll kick off the printer to do that. So I think that's probably it. What I'm willing to do also is to open up the 3MF file just to make sure that I had showed you the right settings. And these are the ones that I saved just so that I wouldn't forget all the changes that I made. And I'll kind of point out the changes here once it opens up. It'll take it just a minute to load up here. Okay. So as it loads up here, you'll see a few of those have changed. So everything that I changed is marked with a different color basically. So this allows you to revert back to the original settings on this, but you'll see, like I was showing before, I changed the layer height and I changed the seam position to go back. And that's pretty much it. And also using the ASA is what I did here. So you'll see that it's already gray on that. You may have to change that for your configuration, your setup, especially if you're using an AMS. You'll have to, right click on the or click on the model. Excuse me. Let's go back to prepare. Right click on that and change the filament to whichever one you want to use, depending on how you've got your AMS loaded up. That's pretty much it, and that's kind of the mystery part of it. A lot of details I'm probably leaving out there, but I thought it might be nice for some of you to see the process and how that works. So let's flip back over to the article. He mentions a few different tools here. He linked over to some blue thumb screws that he used, and if you like that style, that's totally fine. You could grab those. One of the things to mention is that he's recommending M3 by 16 millimeters. I believe that's a good length based on what I'm seeing so far. He said you might be able to go a little bit shorter with these, but he had not tested anything below like 12 millimeters. I think he went with the 16, and I think it feels right because you need room. The way this is going to end up is that there's going to be a screw, essentially think of it as a tightener for your struts position. You need to be able to have it long enough to be able to reach your thumbs around it, your fingers around it, to be able to tighten it and untighten that screw. I went with a different set. Let me just go over here. I went with black on mine because I wanted to be a little bit less pop on that. So I found these UXL ones. They're really designed for graphics cards or computer cards here to screw them down onto a motherboard, but they work just fine in this situation. And there's 10 of them for $15.29 that I got. He also mentions an individual tap. My recommendation is if you don't have a tap and die set, you probably want to just go ahead and get a set instead of buying individual taps, because once you realize the power of being able to tap your own 3D prints and get the threads just perfect, either inside or outside. So tap is for interior threads inside of a shape, and the die is for the outside. So if you need to thread the outside, so like if you were creating a plastic bolt, for instance, you need to thread the outside of the shape, you would use a die set. So I went with a 60-piece master tap and die set on this because I did not have one and I wanted one. This one's good. But I will warn you that if you do get this one, the taps are ones that are like the shafts there, and the circular ones are the dies where you kind of thread them on the outside. Just be warned that even though this has a handle, if you lift it up and carry it from the handle, all of these taps are going to fall out of those little slots right there. So it's just one thing to think of. I wasn't expecting that with this. I would expect those to snap in, but they do not on this particular one. But it was a nice and affordable set, and the quality of the parts seemed to be good. It's just I wasn't too impressed with the way that the case was made. Also, he mentions in here that you may need over here on his article here, he mentions that you may need a T-handle here. Well, that comes in most tie and tap and die sets. So this little piece here is part of the handle. Those two, let me see if I can kind of zoom in on this. This is where you would actually put the tap into the end here and screw it on. It works a lot like like an impact drill or a standard electric drill. You could put the tap in the end here, and then this is your handle that goes into this hole right here, and that will allow you to twist it into there. So I used, as he recommended, an M3 tap. And I think it's probably this one right here. It's kind of hard to tell from the pictures here, but it's one of these smaller ones that are in here. I used that and the T-handle, and it worked perfectly for it. Another thing I'll point out is in his video, he mentions somewhere in here about where you'll see that he uses a vise to hold the little 3D printed pieces there. But I found that that probably makes it more difficult. I was able to just hold the pieces because the 3D print already has the start. And I'll zoom in here so you can see. It has the threaded pieces in here. It's just not perfectly printed, so the threads aren't perfect. That's why you need a tap to make those threads perfect in there. When you twist that tap into here, it just works great. So what I did is I just held these pieces and tapped it into it. Now you want that tap to go all the way through from the top through the end, and that way your thread's all the way good, because you're at the end of the day, that 3M screw, thumb screw, is going to go in this side of it, and it's going to come out the other side and go up against the aluminum strut there to hold it in place. So that's going to work great. I noticed the threads are just absolutely perfect after using that, the tap in there. And I think that's probably it. I did go ahead, I needed a center punch, and what this is used for, you'll see that James is talking about it in the video, but this allows you to basically dimple the place where you're going to do some work on the struts there, and this one worked really great from here. I like the handle on it. You can actually turn the handle to change the strength of the tap, so it's got an adjustable tension on it. So I thought that was a nice one and not very expensive at all. So it was nice to have that. So I went ahead and got that piece. Everything else that he lists here, I either had it already or didn't feel the need for it. So for instance, he mentions a nail setter punch here. I've got one of those, but I think you'd be fine with just using a straight screwdriver. The other thing you would need is, if you don't have a Torx screwdriver set, you might want to get one of those. I had one already. You're going to want to hand tighten these when you use that to loosen the struts to take them off of the windows, and when you reinstall them, you don't want to go too incredibly tight with these things, because so hand tightening is preferred over using a drill to do that, or a power screwdriver. I think that's about it, but I thought it might be useful for you guys to see kind of how this all came about. So I'm super excited about this. It's a little bit more work as far as getting it to stay in place, but now I know that it's not going to fail in the field, and I'm tightening the other side as well, so we can just let this loose. But I'm super excited to finally have a working window again. And I noticed, I was watching a video earlier today about the new Winnebago Arca, and I noticed that it also has these acrylic windows in it, the double pane acrylic windows, but they had a completely different strut, and it had a very similar design, but just a little bit more manufactured look. So they weren't metal, thumb screws being used in there. They were nice plastic twists pieces. So I'm glad to see that Lippert and the RV industry is learning a little bit from some of these mistakes, but super excited. If you have any questions about this or how it was done, I'm always happy to help, so please post down in the comments below. But if you like this kind of content, please do subscribe to the channel, hit that notification bell to be notified when new videos come out, and we'll see you in the next video. Take care, everybody. Have a great day.